Let's take a look at systems linear equations, three variables by matrices on a T82 calculator. Now, on my website, mathheals.com, two H's, if you go here, there's a link for graphing calculators. It'll eventually say graphing calculators / technology. If I click that, then I can go into college algebra, and here's all the different videos for the various topics in college algebra, and along with the links for the different calculators. And I'm working my way through them slowly, so you'll see these eventually fill in. I'm working on T82s now. Now, if you're struggling with something in college algebra, you can go up here to the top link. It says math class information. I'll probably eventually change that to lectures. If I click that, then I'll go to college algebra. Here you'll find YouTube videos. So if you want to watch a video on linear equations, you can come here and watch this. This is the exact same lecture I give in my classes. Same explanation, same examples, same everything. Okay. Let's take a look at this one. And we'll look at this problem first. So we got 2x plus y minus 3z is equal to -6. And we got x plus 4y minus z is equal to -5. And 8x minus y plus 5z is equal to 32. Let me double check all that. Okay, now we want to write down the matrix that goes along with this. So I'm going to drop the, let me do it right below it. Okay, so we want to go write down the matrix that goes along with this. The first matrix is going to be just based upon our variables. So we're going to drop our x, y's, and z's and keep the numbers in their signs. So I got 2, 1, -3. Then I got 1, 4, -1. Then 8, -1, 5. Now, on these, some of them don't have numbers. Remember, there's an invisible 1 there. If you're missing the variable, like if this y wasn't even here, you'd put a 0 there. So my x's are in one column, my y's are in one column, and my z's are in one column. Now, our uppercase x would be our variables, which would be x, y, and z. Now b, that's going to be our numbers on the right side. So I got -6, -5, and 32. Okay, now this is all based upon this equation. Ax is equal to b. And if we multiply both sides by the inverse of a, and don't worry about what the inverse is, really doesn't have anything to do with using the calculator. But the theory behind it is the inverse of a times a cancels, and then we got x, which is our variables, x, y, z, is equal to the inverse of a times b. Well, let's go ahead and put these matrices in and see what we get. Okay, so I'm going to press clear that out. I'll press my matrix button. I'm going to right arrow twice over to edit, and I'll do enter on A. Now this is a 3 by 3, so do 3 enter, 3 enter. And then I'll type in each number, pressing enter after each one. So I got 2 enter, 1 enter, -3 enter, 1 enter, 4 enter, -1 enter, 8 enter, -1 enter, and 5 enter. Now let me double check my numbers and everything. That looks good. So I exit out, do second mode. Now go back to my matrix menu, and I'm going to right arrow over to edit, and now I'm going to down arrow to B and press enter. And it's asking me for rows by columns. Well, this one has 3 rows, 1 column. So do a 3 enter, 1 enter. You can't mess that up. After you type that in, you see if it looks like what you have written down in your paper. And mine does. So I'll put in -6, enter, -5, enter, and 32, enter. Then I'm going to exit out to a second mode. Well, wanted to plug this in, so I want the inverse of a times b. So I'm going to go into my matrix menu. I'll do enter on A. Now this button here looks like x and -1. That's our inverse button. So push that, then times, and I'll go to matrix menu, down arrow to B, and press enter, and enter again. Now, what it comes up with is our answers, and it'll be in the form of the order that your variables are. See how my x, y, z, so it matches the x matrix right here. So x is 2, y is -1, and z is 3. So 2, -1, 3. 2, -1, 3. And that's our first answer. Okay, let's look at our second example. So here we got x minus 3y plus z is equal to 8. And 4x plus y minus 2z is equal to 7. And 5x minus y plus 3z is equal to 4. Now let me double check my numbers. 8, 7, 4, 1, -2, 3, 1, -2, 3, -3, 1, -1, -3, 1, -1, 1, 4, 5. 1, 4, 5. Okay, that looks good. Okay, so we want to write down the matrix that goes along with this. First thing we'll do is look at just our variables. And we'll drop the x's, y's, and z's and keep the numbers in their signs. So I got 1, -3, 1, 4, 1, -2, 5, -1, 3. Double check that. Okay, now our variable matrix. That'll be our x, y, and z. And then b will be our constant values on the right side, which would be 8, 7, 4. Okay, well, let's go input those in. Okay, so press clear to clear that out. I'm going to go to my matrix button, right arrow twice over to edit, enter on A. Size of this matrix is a 3 by 3. It doesn't have to be. It can be a 4 by 4. It works the same way. I'll do 3 enter, 3 enter. And I got 1 enter, -3 enter, 1, 4, 1, -2, 5, -1, and 3. Okay, let me double check that. That looks good. So exit out, second mode. Go back in my matrix menu, go to edit, right arrow twice, down arrow to B, and press enter on it. Rows by columns. So this is a 3 by 1, so do 3 enter, 1 enter. And I got 8 enter, 7 enter, 4 enter. Then I'll exit out. Again, what we're wanting to do is take the inverse of A times B. So we're wanting to do this formula right here. Well, I'm going to go to matrix menu. I'm under the name, so I do enter on A. Then I'll push this button, looks like x and -1, that's our inverse. Times, and I'm not sure if you even need times there. And then B, so I do matrix, and then I'll down arrow to B, and press enter on it, and then press enter again. Now we get decimals. We don't want decimals at all, if we can help it. So if you get decimals on this process, you can do math, enter, enter, and now change them to fraction. So this is our x, 42 over 9. This is our y, -83 over 29. And that's 42 over 29. And this is -59 over 29, or z. So 42 over 29. And -83 over 29. And -59 over 29. And those are answers. And that's how you solve a system of linear equations with 3 equations, 3 variables on a TI-2 calculator.